Hello everyone. In this, we will understand how do we derive the derivatives of inverse trigonometric functions. The first one, if y is equal to sine inverse of x, then find dy by dx. So first of all, we will rewrite this y equal to sine inverse of x. That means sine y should be equal to x. Now, let us differentiate both sides with respect to x. So what will happen if I differentiate sine y, it is cos y, but it is to be differentiated with respect to x, so we'll be multiplying it with dy by dx. That is equal to, if I differentiate x with respect to x, it is 1, which means our dy by dx is nothing but 1 divided by cos y. 1 divided by cos y. Now, since we have this sine y as x, that means our sine square y is nothing but x square, or I will first add both sides with 1. 1 plus sine square y is equal to x square. 1 plus sine square y, sorry, I should do it on both sides. Sorry. Since I am interested in bringing it to cos y, I should I should multiply both sides by negative. Then I will add 1. 1 minus of sine square y is equal to 1 minus of x square. 1 minus sine square y is nothing but cos square y. So it becomes 1 minus of x square, which means cos y will be root of 1 minus of x square. So that we will be substituting here. So it will become 1 divided by root of 1 minus of x square. That is the derivative of sine inverse of x. This, it is given as y is equal to cos inverse of x. We have to find out what is dy by dx. Again, let us rewrite y equal to cos inverse of x. And that means cos of y is equal to x. Differentiating both sides with respect to x, we get, if I differentiate cos y, it is minus of sine y, but since we have to do it with respect to x, we will be multiplying it with dy by dx. And if I differentiate x with respect to x, it is 1, which means our dy by dx is 1 divided by minus sine y, or minus 1 by sine y. Now we need to write this sine y in terms of, we have to express in terms of x. So first of all, we'll be taking this cos y equal to x. If I square it on both sides, it is cos square y is equal to x square. And subtracting both sides by from 1, we get 1 minus cos square y is 1 minus of x square, which means 1 minus cos square of y is sine square of y, and that is 1 minus x square. We are interested in sine y, so we need to take square root on both sides, so we get 1 minus of x square under root. So this dy by dx will be minus 1 divided by root of 1 minus of x square. So if y is cos inverse of x, then dy by dx is minus 1 divided by square root of 1 minus of x square. It is given as y is equal to tan inverse of x, then we need to find what is dy by dx. So let us rewrite y is equal to tan inverse of x, which means tan y is equal to x. Differentiating with respect to x on both sides, what do we get? If I differentiate tan y, it is secant square y, and then since it is a function of x, we have to multiply dy by dx is equal to 1, or we can say dy by dx is 1 divided by secant square of y. And 1 divided by secant square of y is nothing but cos square y. Now, let us come back to this. Let us come back to this tan y equal to x, which means tan square y is equal to x square. Or we can say 1 plus tan square of y is equal to 1 plus x square. Or we can say secant square of y is 1 plus x square. So I think we don't need this cos square y. Directly we can substitute here as this is equal to 1 divided by 1 plus x square. Means if y is tan inverse of x, then dy by dx is 1 over 1 plus x square. That will be the derivative of tan inverse of x. If y is equal to cosecant inverse of x, then find dy by dx. So first of all, let us rewrite this y is equal to cosecant inverse of x, which means that cosecant y should be equal to x. Now, differentiating with respect to x on both sides, if I differentiate cosecant of x, it will be minus cot y cosecant y dy by dx. That should be equated to, because if I differentiate x, it is 1, which means our dy by dx is 1 divided by negative cot y cosecant y. Now, since we have this cosecant y equal to x, if I square it on both sides, it becomes cosecant square y equal to x square. Or I can put inverse, means I can put this as sine square y will be 1 by x square. And then minus sine square y will be minus 1 by x square, which means 1 minus sine square y is 1 minus of x square, or cos square y equal to x square minus 1 by x square. Now, cot y is nothing but cos y by sine y. So, which is cos y, which is root of x square minus 1 by root of x square is nothing but x, and sine square y is 1 by x. So this and this gets cancelled. You get square root of x square minus 1. Now, cosecant, if we look into this, sine square y is 1 by x square. Cosecant square y is already available. So cosecant y is nothing but x. So we can put this as minus 1 divided by root of x square minus 1, and cosecant y is nothing but x, or we can rewrite it as 1 divided by x root of x square minus 1. That is the derivative of cosecant inverse y. If y is equal to secant inverse of x, then find dy by dx. So y is secant inverse of x, which means secant y is x. Now differentiating with respect to x on both sides, if I differentiate secant y, it is tan y secant y multiplied by dy by dx is equal to 1, which means dy by dx is 1 divided by tan y secant y. Now from here we can say secant square of y equal to x square, or secant square y minus 1 equal to x square minus 1. Secant square y minus 1 is tan square of y, which is x square minus 1. That means tan y will be square root of x square minus 1. So this dy by dx now can be written in terms of x as 1 divided by tan y. We know it is square root of x square minus 1. Secant y is nothing but x. So we can write it as x square root of x square minus 1. That is the derivative of secant inverse of x. If y is equal to cot inverse of x, then find dy by dx. So y is cot inverse of x, which means cot y is equal to x. Now differentiating cot y with respect to x, we get minus cosecant square y times dy by dx equal to x. I'm sorry, equal to 1. If I differentiate x with respect to x is 1. So which means dy by dx will be 1 divided by minus cosecant square of y, or we can write it as minus 1 divided by cosecant square of y. Now coming to this, coming to this cot y equal to x, which means cot square y equal to x square. That means 1 plus cot square y equal to 1 plus x square. 1 plus cot square y is nothing but cosecant square of y, and that is 1 plus x square. So that means this dy by dx can be written as minus 1 divided by 1 plus x square. So that is the derivative of cot inverse of x, which is minus 1 divided by 1 plus x square.